Hi 6th graders, this is Mrs. Gall. Today I'm going to talk you through monomials and how we find the GCF and LCM of numbers that involve variables. So for an example, we might start out with a set of numbers like this. 18 times y to the second, and another number might be 54 times y to the third. So those y's are connected to those numbers, which means times, and this is kind of the setup that we'll see. I should say I would definitely recommend pausing and opening up your notebook. Write these down if it's something that you're watching for the first time. So please write these down. Press play when you're ready to keep going. What we're going to do in a setup like this is start by focusing on just the number part, the 18 and the 54. And we want to set it up in the cake method, and we ask ourselves, what's something I could divide both of those numbers by? The bigger factor, the better. So maybe you identified that they could be divided by 2 or 3, but actually 6 or 9 are going to be our better factors to choose there. Let's say I saw 9 right away. 18 divided by 9 is 2. My y has not changed yet. I haven't done anything with it, so I'm just going to bring that down as y to the second. And then 54 divided by 9 is 6. Again, I'm going to write that answer below and bring down my y. It's a y to the third. And I'm not going to change it yet because I haven't done anything different yet. I ask myself again, with my new numbers 2 and 6, is there anything I can divide these two numbers by? Yeah, actually there is. They are both even, so I can divide this row by a 2. 2 divided by 2 is 1. My y to the second stays. 6 divided by 2 is 3. My y to the third stays. Now I've gotten my whole numbers down to 1 and 3. I can't get those down any further, so I'm done with the whole numbers. But now I need to move on to my variables, my letters. I have y to the second and y to the third. What this is saying, you guys, is I have 2 y's in the first set and 3 y's in the second set. Because remember, y to the second is the same thing as y times y, and y to the third is the same thing as y times y times y. So we're going to say how many y's can we take out of this row? But we have to be able to take out the same number of y's from each set. So what I tell you to look for is look for the smaller y, which would be y to the second. That means you can take out y to the second from both of those sets. If I take out y to the second here, I'm getting rid of all of those y's in that first set. So all I would be left with is my 1. If I take out 2 of those y's from this set here, how many y's would I be left with? Well, if I go down and look at this here, if I take out 2 of those y's, I would be left with just 1 y. It's kind of like subtracting them out. So I will have 1 y left there. Notice I kept bringing down my whole numbers, my 1 and my 3. That's important. Notice I have no more y's in the first set, so that means I can't take out any more y's. I've done as much work as I can here. Now I go over and I look at my side for my GCF. I multiply all of those pieces together. I'm getting myself some more workspace down here. When I multiply those pieces together, I focus on my whole numbers first. So I see 9 times 2. 9 times 2 gives me 18. So that's the number part of my GCF. And then I have y squared. I need to include that in my answer, so it just kind of gets tacked on the end, because if I take 18 times y squared, another way to write that is 18 connected to my y squared. That means that's the biggest GCF I can take out of both 18 y squared and 54 times y to the third. I can take out an 18 from those whole numbers, and I can take out a y squared from both of those sets of y's. My LCM, I find the same way I would in a typical problem. I draw an L along all of those numbers on the outside. We already knew that this side totaled 18 y to the second. And if I look down here, 1 times 3 is 3, and then I have a y there. So down here, I'm going to get 3y. So I have 18 times 3 that I need to focus on for the number part. And I get 54 for the number part. And then I have a y and a y squared. What that is saying, you guys, is it's like if this is y squared, y times y, and then I need to multiply it by another y, how many y's am I up to? 3. It's kind of like adding them together. So I have y to the third for my total y's. That means if I were to multiply by y squared and 18 times y squared and 54 times y to the third, they could both meet up at 54 times y to the third. So those are my GCF and LCM for this set of numbers. One thing I want you to be aware of, your variable, your letters, for the GCF will usually be the smallest version that you have of your variable in your starting problem. So notice if I look at my y's in my starting problem, I had a y to the second and a y to the third. My GCF is usually going to be the smaller version of that, y to the second. And then my LCM is usually going to be the larger version of my variables, which was y to the third. That's just something to keep in mind if that helps you as we're moving forward. That's a lot to process. Let's do another example. Let's look at 80 x to the third times y. So now I have 2 variables in there. And then my other number is going to be 30 times x to the second times y. I'm going to draw my cake layer around this set of numbers. Start by focusing on your numbers, 80 and 30. What could I divide those both by? 10 is a great choice. Let's start there. 80 divided by 10 is 8. Your x's and y's stay the same for now. 30 divided by 10 is 3. Your x's and y's stay the same and get brought down for now. Still focus on the numbers. Is there anything left to take out of 8 and 3? No. So now we move over to your variables, your letters. Start by just focusing on one letter. Let's focus on x. We have x to the third and x to the second. Just a reminder that x to the third means x times x times x, and x to the second means x times x. How many x's can we take out of both of those sets? Both sets have 2 x's that we can take out of them. So that would be x to the second. We can't take out 3 because this set here doesn't have 3. So we can only take out the smaller number. So we're going to take out x to the second. If I take out 2 x's from my x to the third, how many x's are left? Just 1. So right here, this x to the third is going to turn in x to the first, which is the same thing as just 1. So you can put the x to the 1, or you can just leave it as x. A reminder that your 8 just drops down like it was. We're not focusing on the y's right now, so I'm just going to bring down my y. Go to my second number now. 3 does not get affected, so I just bring down my 3. If I had x to the second down here, and I'm taking out 2 of those x's, am I going to have any x's left in that second set? No, they're totally going to disappear. So I don't have any x's in my 3 connected to my 3. All I'll have now is that y for now. We are done with the x's. Let's now go over to the y. How many y's do we have in both numbers? All I see is a y in each number. If we don't see a little exponent here, that means that they're both there one time. So if they're both there one time, how many y's can I take out of both? I can take out 1 y from each. if I take out one y from each, my 8 stays the same. Oops. My x stays the same. Remember, x to the 1 is just like x, so I can get rid of that 1. If I take out this y, I have no y's left for this set, so I'm not going to bring anything down. For my other set, my 3 gets dropped down. If I'm going to take one y out of here, it's kind of like subtracting it out of there. I'm not going to have a y left down at the bottom. I am out of pieces to divide by, to take out of these sets of numbers, because 8 and 3 can't be divided any further. I only have x in one number, so I can't take an x out of both, and I don't have any y's left at all. So now I stop and I find my GCF and LCM. My GCF is always found on the side of my cake right here. I multiply those numbers together to get my GCF. 10 times x to the second times y. 10 does not have any other numbers to get multiplied by. All it has is variables. So when all it has is variables, we just set them all right next to each other, because that means that they're being multiplied together. So I have 10 times x to the second times y. That is the greatest factor I can take out of both of those numbers I started with. Let's move over to the LCM. Draw your big L. Remember that over here on the left, you already found out that this was 10 times x to the second times y. What about down here? What does this get us? Well, 8 times 3 is 24. And then I just have one variable, my x, so that gets set at the back. 24 times x is 24x. Now I have to multiply those two pieces together. I'm going to slide down so I have a little bit more workspace. The 10x squared y, I'm going to use a dot for multiply. I need to multiply that by 24 times x. So look for your like pieces. We need to multiply our two numbers together, 24 and 10. If I multiply 24 and 10, I get 240. So we took care of those. Now I see some x's. I have x to the second and x to the third. If I have x to the second right there, and I need to, I'm sorry, I said x to the third, I meant just one x. If I have x to the second and I need to multiply it by one more x, how many x's do we have now? 3. So we can abbreviate that by saying x to the third. And then how many y's do I have? Just one. So that y just gets tacked on the end like this. 240 x to the third times y. Go back up. Remember that clue I gave you? Your GCF should have the smallest version of your variables. So was x to the second our smallest x in our starting numbers? Yeah. Was y our smallest y in our numbers? Yeah, because both of these were just a y. For your LCM, you should have the largest possible version of your variables. Was x to the third our largest x? Yep. And was y to the first, or just y, our largest y? Yeah, because they were both just y. So that means our GCF is 10 times x to the second times y, and our LCM is 240, times x to the third times y. Forgot that y there. Okay, you guys, let's try one on your own. Let's try 20 a to the third times b and 32 a to the second times b. Pause the video to try this on your own, and then I'll walk through it for you. Press play when you're ready to hear the answer. Start by focusing on your numbers, 20 and 32. I could divide them both by 4. That gives me 5. The letters or variables stay the same. And 8. Letters and variables stay the same. It's supposed to be a 2. It looked like a B. Let me erase that. All right, you guys. 5 and 8, I can't go any further with those numbers. So now let's focus on your letters. A to the third and A to the second. What can I take out of both of those? I can take out an A to the second out of both of those. Okay, so that keeps the 5 and the 8 the same. If I take A to the second out of A to the third, how many A's are left? If you take 2 A's out of there, only 1 A is left here, and the B stays the same. If you take 2 A's out of A times A, how many A's are left? None. So there's no more A's in this set. All that's left is your B. Okay, now let's go over to the B's. We have 1 B in each. So how many B's can we take out of there? 1 B in each. That's going to cancel out both of those B's. So we have no B's left. You're left with 5A and 8. Now we go and find our GCF and LCM. GCF is found on the side. 4 times A squared times B means our GCF is 4A squared B. Just those numbers all set together. Our LCM, all numbers on the outside multiplied together. Focus on your numbers first. You had a 4, a 5, and an 8. I know 5 times 8 is 40. 40 times 4 is 160. And now focus on your letters. We have A to the second times A. That's A to the second times another A. We're up to A to the third. And then I just have 1 B without anything else, so that 1 B gets added in there. So GCF was 4A squared times B. LCM was 160 times A to the third times B. All right, you guys, this is definitely a tricky skill. There's a lot of pieces. The variables kind of can throw us for a loop. Try your best. Rewatch the video as needed. Check in with your teacher if you have any questions.